Today we're in section 5.3, solving linear systems with elimination. Depending on the type of system will depend on if I graph, substitute, or eliminate to solve the system. But remember, all of my solutions are ordered pairs. That's the solution I'm seeking. Which method I use will be determined by the type of system that I have and basically what my values are. All right, so in example 1, we're going to look at each system individually. So this first system, x plus 3y equals negative 2, and x minus 3y equals 16. Make sure you write them stacked on top of each other, just like I have here on the slide. Okay, so don't do them side by side with elimination. We want them vertical. So with elimination, I am looking for, here's my key word, I'm looking for opposites, okay? And what I mean by opposites are variables, so either the x variables or the y variables that are opposite each other in value, all right? So most of the time, the majority of the time, actually all of the time, I can add to eliminate, add the equations to eliminate. I could also subtract, but sometimes that gets confusing. How do I know when to add or subtract? So let's just add to eliminate, okay? All right, so what I'm looking for is, are my x's opposite? Are they opposite? Yeah. No, they're the same. X plus x is 2x. But are my y's opposite? Yeah. They are. So here's what's going to happen. My y terms cancel out. And now I'm going to add the rest of the terms in the equations. X plus x is 2x. X plus x is 2x. My y's cancel. And what's negative 2 plus 16? 14. Okay, now how can I solve for x?
Divide by 2.
Divide by 2. And x equals 7. So now I have the first part to my solution. Now what can I do with my value of 7 to solve for y? This is similar to all the other methods that we've learned. I could do what? Plug it back into the original equation. It doesn't matter which one. I'm just going to choose one of them. I'll choose the first one. Plug in 7 for x. 7 plus 3y equals negative 2. So I take my x value, I plug it back into one of the original equations, and now I can solve for y. That's a two-step equation. Anybody tell me what my next step would be to solve for y? What's going to be my next step? Ethan?
Subtract 7.
Very good. Subtract 7 from both sides. 3y equals negative 9. Negative 9. Now what am I going to do? Divide both sides by 3, and y equals negative 3, and I have my solution, 7, negative 3. So again, with all the methods, my solution is an ordered pair. That's what I'm looking for. All right, I want you to go ahead and write down the second system. Okay, go ahead and write the second system down, and as you're writing it down, look for which variable, x or y, has the opposite values. So for x or y, which one is opposite? The y term, right? I mean, 2x and 4x are clearly not opposite each other, okay? But negative y plus y, those are opposite, right? So they're going to cancel out completely, and now I'm going to add the rest of the equations together. What's 2x plus 4x? 6x. What's 9 plus 21? 30. Okay, and now what would I do to both sides? Divide by 6. X equals 5. Now that I have my x term, how can I find y? What can I do? Plug it back in. Doesn't matter which one. Plug it back in, and now you solve for y on your own. And I'm going to come check. All right, when I plug 5 back in, 2 times 5 minus y equals 9. But what number is understood in front of the y? a 1y, okay? It's really important when there's a negative in front of the variable, but no number, that you put the 1 there, because that reminds you that there's a number there that I have to get rid of. I can't have a negative variable. All right, so now when I subtract 10 from both sides, I get negative 1y equals negative 1. I divide both sides by negative 1, and I get positive 1. Okay, so you lose a point on that if you had the wrong sign. All right, so pretty good for the second one, guys. All right, let's do another one. All right, so lots of practice here. Really, that's the only way that we're going to get a grasp on these concepts, is by practicing. The more I talk, the more confusing it gets. So I don't want to just keep talking. I want to give you guys a chance to practice. All right, so solve by elimination. So as you're writing down the system, we're focusing on this first system on the left. Look for the terms that are opposite, and then try to simplify it and solve for the other variable. Okay, so which variable is opposite, completely opposite? Yeah, x minus x. X minus x cancels, okay? And then I get 3y minus, and guys, again, it's very helpful if you put an understood 1 out in front of the y. It's not going to be there in the problem, but now I can clearly see 3 minus 1 is 2. 2y equals 2, and y equals 1. Now, what can I do with that? Y equals 1. How do I find x using that information? Plug it back in. All right, so go ahead and do that and find your x value. So we plug 1 back in, and I just plugged it in for the second one. I saw a lot of you guys did the first one, but it doesn't matter. Negative x minus 1 equals negative 3. I add 1. Negative 3 plus 1 is negative 2. Negative 1, x equals negative 2, divide both sides, and I get 2, 1. 2, 1. All right, who got 2, 1 for your answer, 2, 1? All right, that's good. For the third one, we're doing well, Maya.
I got that answer, but I did not do it like that. I
Okay.
did x plus 3 times.
Yes, correct. So she's saying that she got the same answer, but she plugged her y value back into the first equation. I did the second equation, but that doesn't matter. As long as you plug it back into one of them, that's going to be perfectly fine, and you'll get the same answer. This is the last one for example 1. X minus 2y equals negative 7, and 3x plus 2y equals 3. So I'm really hoping that you can start to finish. Go ahead and do this one, and raise your hand when you have the answer. I'm going to come check. Okay, which variable cancels, x or y?
Y.
The y variable cancels, and I get 4x equals negative 4. Divide both sides by 4, and x equals negative 1. Raise your hand if you got negative 1. Awesome. Okay, now I plug it back in. I just did the first one. If you did the second one, that's fine too. Negative 1 minus 2y equals negative 7. What's my next step? What's my next step according to what you guys just did on your paper, Elizabeth? Plus 1 to both sides. Now, negative 2y equals negative 6. Divide both sides by negative 2, and y is 3. Okay, positive 3. Okay, who got them both right? That's awesome, guys. Great job. All right, now in example 2, I'm just going to do one of these just because we're, starting to get pressed on time. On example 2, I want you to write down this system, and I'm going to ask you what is different about this system compared to the other ones we've solved. All right, so go ahead and copy it down, and we'll talk about it in just a sec. Okay, so what do we notice about the values in this system? What do we notice about the values? Are there any opposites?
No.
There's no opposites. My x and my y, they're not opposites. Okay, so that doesn't mean that I can't make one of the equations to have an opposite value. All right, so here's what this means. From 4 to 5, does 4 go into 5 evenly? No. But can 2 go into 6 evenly?
Yes.
So I can multiply the entire equation, second equation, by some number that would make it the opposite of negative 6x. So what can I multiply 2 by to get to 6? 3. Okay, but here's the challenge though. If I multiply 3 times negative 2, is that going to be the opposite of negative 6? What's 3 times negative 2?
6.
Negative 6. That negative 6 is not the opposite of negative 6. So I have to multiply by negative 3. I need to make it the exact opposite. All right, so negative 3 times negative 2x is positive 6x. But I can't stop there. I need to keep distributing the negative 3 through the whole equation. All right, so negative 3 times negative 4y is what? 12y. And then negative 3 times 14 is? Negative 42. So if you say positive 42, you're dead in the water. Okay, so the signs make all the difference. Now that I have this equation, I'm going to rewrite the first equation underneath it. Negative 6x plus 5y equals 25, and I'm ready to eliminate.
All right.
Okay, so go ahead and eliminate and solve for y. Okay, so my x's cancel, and I get 17y equals negative 17. Divide by 17, and y equals negative 1. All right, who got negative 1? Okay. All right, so now that y equals negative 1, what do I do with that? What do I do with it, guys? Plug it back in. Okay, very good. Plug it back in. So negative 6x minus 5 times plus 5 times negative 1 equals 25. All right, now go ahead and solve for x. Add 5 to both sides. We've got negative 6x minus 5 equals 25. So add 5 to both sides. And negative 6x equals 30. Divide by negative 6. And x equals negative 5. Now put that into an ordered pair and you're done. Negative 5, negative 1. And you're done. Okay? All right, so solving by elimination when there's not a clear opposite scenario to start with. All right, so now let's look at the last problem. You buy 8 hostas and 15 daylilies. These are just plants for $193. Your friend buys 3 hostas and 12 daylilies for $117. So how much is each daylily? So without knowing how much they cost, just knowing how many they bought, I can figure out the cost, but I need to set up an equation. All right. So my first equation, I'm just going to write it in the order that I'm reading it. 8x. 8 times, I don't know how many hostas, plus 15 daylilies, I'm just going to make that my y value, equals 193. Now I want you to make the second scenario match that one in terms of variables. Okay, so with the information from your friend, go ahead and make your second equation. Yeah, very good. Okay, so now I have an added challenge in this problem. Okay, so I clearly do not see any opposites here. Okay, any opposite values, but I also do not see values that can be evenly divided into the other value. Do you agree? Okay, so now I need to choose. Now I'm going to actually change both equations, but I need to find a least common multiple of one of the variables. I can choose x or y. Okay, I'm going to choose x purely because these numbers are smaller. Okay, so I know that 3 does not go into 8, so I need to go up to the next multiple of 8, which is what?
9.
16. Okay, I'm going by multiples of 8 because I need it to be I need it to be divisible by 8 also. So 8, 3 does not go into. 16, the next multiple of 8. 3 does not go into 16. What's the next multiple of 8? Guys, 24. Okay, so now 24 is my LCM. So what would I need to multiply 8 by to get 24? 3. So I multiply the entire equation by 3. Okay, 3 times 8x, this is the longest one for sure. 3 times 15y, and 3 times 193. I need to distribute it, but I'm creating an equivalent equation that now is going to give me the opportunity to cancel one of my variables. Okay? 4x, what's 3 times 15y? 45y equals, and I'm just going to go ahead and tell you it's 579. Okay? So now the second equation. All right, so now what would I need to multiply the second equation by? Get this, guys, get this. So that 24x is now the opposite sign 24x. What would I need to multiply it by? Negative 8. Okay, I need to multiply it by negative 8. So that now it's negative 24x. I need to make it the opposite. Okay? So if I multiplied the first one by negative 8, I multiply the second term and the third term by negative 8. Okay? So negative 8 times 12y is negative 96y. And negative 8 times 117 is negative, sorry, I lost it. What is it? 936. Negative 936. And now I can add across the whole equation. My x's will cancel, which is what I needed, and I can solve for y. Go ahead and do that. All right, so what is 45 minus 96?
Negative 51.
Yep, negative 51 equals, and when you subtract, wait, hold on. 579 minus 936 is negative 357. Okay, divide by negative 51. And y equals 7. Now, it would be really nice if y stood for daylilies, so I don't have to plug it back in and solve for x. Did it ask for, is y daylilies or hostas? Y is daylilies, yay, so I don't have to plug it back in. I don't care how many hostas there are. It just asked me or the cost of the daylily, and so that is $7.
That's it. I did all the.
Yeah, it's $7. So I'm going to say daylilies. I need to answer the question. Daylily is $7. Okay, now, could I figure out how much the hostas are by plugging it back in? Yeah, I could still do that. Just the problem didn't ask me to, so I'm not going to do the extra work. All right, if you understand that, that's everything you need to know for 5.3 elimination.